All right, we're going to talk about some quadratic key features here. I'm going to show you how to do everything by hand, which is how you need to do it on your knowledge check. But I'm also going to show you how to check it on your calculator, or at least most of these things. Not everything can be done on your calculator. And then in the next lesson, if you know how to do it on a calculator, you should do the calculator. So this lesson, you have to learn it by hand, but you can check with the calculator. And then the next one, fully calculator if you want. So quadratic functions, definitions here. Quadratic functions are functions with exponent of 2, largest exponent of 2. So 5x squared plus 7 is quadratic. 3x squared plus 9x minus 8 is quadratic. Largest exponent is 2. Vertex is a coordinate point of the highest or lowest point on the graph. I'll show you an example of what that looks like in a moment. Y-intercept. I know you know this one. Y-intercept, where it crosses the y-axis. Roots, x-intercepts. Zeros, x-intercepts. So if I ask you to find the roots or the zeros or the x-intercepts or the solutions, you're finding the same thing. End behavior, what the graph does at the ends. Quadratics make a parabola. A parabola looks like a U or an upside down U. So your ends, your end behavior, is going to either go in an upward direction or in a downward direction. We'll talk a little bit more about that when we get to that part. The domain are the x values of a function, and the range are the y values of a function. All right, let's get to the math. The vertex. So the vertex is the highest or lowest point of a graph. So first I'm going to show you, this is a quadratic function, makes a U shape. The vertex is wherever the lowest point, coordinate point is on that graph. All right, so that's one example. One moment, I'm going to bring you up another example for you. Here's another one. There is my vertex. All right, so first let's talk about how to find it by hand. Then we'll talk about how to find it using the calculator, or how to check it with the calculator. So the vertex is a coordinate point. You need both an x and a y value. The x value of a vertex has this little formula, negative b divided by 2a, where a and b are the a and b values of your function. After you have the x value, you take that number, plug it into x in your function, that gives you your y value. So in this example, to find my vertex, I'm going to take, for the x value, negative, my b value is 12, divided by 2 times my a value, that would be negative 12 over 6, which would be negative 2. All right, negative 12 divided by 6 is negative 2. That is the x value. Now to find the y value, I'm just going to take that number and plug it in to my function. And I don't need you to show me all of the work of how do you get that answer. Once you have that, just type it in your calculator, just like that. So you get negative 19. So your vertex for this function is negative 2, negative 19. All right, now I'm going to show you how to check that on your calculator. Because remember, if you know how to do that, then in the next lesson, you get to just use your calculator. So I know some of you do have different calculators. So if this does not work for your calculator, then let me know and I'll try and figure out how to do it on yours. So first right here is a button that says y equals, you're going to go to that. And you need to type your function in. It was 3x squared plus 12x minus 7. When I typed in my x's, I made sure I typed this button right here. And I made sure for this, I used a minus symbol, my minus sign, and not a negative. After that, you're going to go to this button here that says graph. I know it's kind of glaring, it's hard to see this, but this one right here, somehow you can see, says the word graph. Right there, graph. Hit that. Your graph's going to pop up. Okay, and I know you can't see the full graph. If at any point it is bad enough and you need to see it differently, then let me know, and that is something I will help you with at all times. Quizzes, knowledge checks, practice, tests, everything. If you need a different view of your graph, you just need to let me know that, and I will help you. But what I want to point out is, see how this is opening? You can tell that's getting wider up here. So your parabola has a vertex somewhere down here because it's opening upward. So I need to know that. I need to know that it's somewhere down here and not somewhere up here. Then you're going to go second, trace. Okay. The reason I need to know it was down here is because I need to know if I'm looking for a minimum or a maximum. Well, if it's down here, that's a minimum. So I'm going to go to number 3 and hit enter. I also need to know it's somewhere down here because the first question it asked me is for a left bound. If my point is somewhere down here, I need to be left of that point. See this little blinking cursor? I am not left of where I think my minimum is. So I'm just going to arrow left until I come up anywhere over here. I'm definitely left of my vertex, and I'm going to hit enter. Now I need to go to the right of it. Once I pop back up over here, anywhere over there, I'm going to hit enter. And then it just says guess, and I'm going to hit enter. And it says -2, -19. Perfect. That's what we had. That's how you find your vertex and then how you check it. In this lesson, you have to show your work, but you can check it on your calculator. Y-intercept is really easy because your y-intercept is on the y-axis. And if you're on the y-axis, then all of your x values are 0. And if all of your x values are 0, then you're going to do 0 squared is 0 times 3 is 0. 12 times 0 is 0. 0 plus 0 is 0. 0 minus 7 is -7. A y-intercept, though, is a coordinate point. So once you know that your y-intercept is just whatever C is, then you have a coordinate point, 0, -7. That's your y-intercept for this function. I don't really need work for this one, but I do need to make sure, or you need to make sure, it's a coordinate point. Not that you should really need to check that one, but I'm going to show you how to check this one. Function has to be typed in. Second, trace. It's where all your things are. Then we can go to where it says value. I know you're going to want to go to intersect. That's not what I'm looking for. I'm not looking for an intersect. I'm looking for an intercept. Different. I can go to value. My x value needs to be 0. I get 0, -7. Pretty easy. X-intercepts, roots, and zeros. I'm not going to go through this in this set of notes. You have 3 methods that we have talked about in 6.1, 6.2, 6.3. Factoring, completing the square, and quadratic formula. Factoring only works in some cases. Factoring only works if you have a real and rational answer that has to be able to factor. Completing the square and quadratic formula always works, but sometimes they're more complicated than factoring. Factoring can be really, really easy in some cases. I don't care which one you want to do. If you want to factor, though, just keep in mind, if it can't factor, that doesn't mean there are no x-intercepts. It means you have to try completing the square or quadratic formula. However, in this lesson, we are now finding x-intercepts. So just like for the y-intercept, I need a coordinate point. For your x-intercepts, I need your coordinate points. So I have 2 x-intercepts here. I need coordinate points. So whatever your x value is, comma 0, and then whatever your other x value is, comma 0. End behavior. Okay. Your graph will either open up or open down based on your a value, the number in front of your x squared. If it's bigger than 0, so if it's positive, it's going to open up. And if it's less than 0, if it was negative, it's going to open down. But I don't want to just have you say up or down. End behavior is talking about when your graph is going left, what's happening, and when it's going right, what's happening. So if your graph is opening up, it looks something like this. And if it's opening down, it looks something like this. So when I'm left, I'm going up. And when I'm right, I'm going up. Whereas over here, when I'm going left, I'm going down. And I'm right, I'm going down. So your end behavior is going to use what is called limit notation. I'm going to take the limit, and I abbreviate that with the letters LIM. And underneath that, you're going to put x with an arrow, negative infinity. That is said the limit as x goes to negative infinity. Now, if my graph opens up, as my x's are going to negative infinity, that's going to the left. If your x goes to negative infinity on a graph, that's going in a left direction. If my graph opens up, then as I'm going to the left, I'm going up. And in this specific lesson, in all quadratics, when you go left, if it goes up, then if you're going right, it's also going to go up. So this is going to also equal the limit as x goes to positive infinity. So in both cases, if you are opening up, then as you go left and as you go right, you are headed towards positive infinity. That whole thing is your end behavior if you are opening up, which is what this function is doing. But let's talk about what if you're opening down so you can see that example. If I'm opening down, then I'm still going to have the first two parts are the exact same. Because those are what I'm looking at. The limit as x goes to negative infinity is I'm looking at it going to the left. And the limit as x goes to positive infinity, I'm looking at it going to the right. What is your graph doing in the left and right directions? It's going down. So in this one, it's now going to equal negative infinity. So the limit as x goes to negative infinity, in both cases, is talking about going left. And the limit as x goes to positive infinity, in both cases, is talking about going right. Your answer is what you put after the last equal sign, is this right here. I'm going up or I'm going down. These first two pieces are the same because those are not your answers. Those are your, like, what are we doing? Your answer is either infinity or negative infinity. That is your end behavior. Domain. It's really easy. Domain are all the x values. That means all the x values that could work for your function. Well, in this function, every x value will always work. I could ask you in this function to plug in 7. I could ask you to plug in 7.2. I can ask you to plug in negative 18. I could ask you to plug in 1,005,786.94. I can ask you to plug in any number and you will get an answer. So your domain for all quadratic functions is all real numbers. And yes, you need to have the word real because we know that imaginary numbers exist, and not all imaginary numbers will necessarily work. Now let's talk about your range. Your range is not all real numbers, because if I come back to my graph here, not every number is going to have a y value. Let me show you why not. If I come down here, my parabola doesn't go down there. It starts here and goes up. So only y values from this dot up will have a y value. But then every y value up will always have an answer. And if your graph opened upside down, if it looked like this, then from here down, those y values work. So your range is not all real numbers. Your range is going to be what is called interval notation. Interval notation uses parentheses or squared off brackets. If your graph opens up, then your y values are greater than whatever the y value of your vertex is, which for our function, remember, was negative 19. And our graph opens up because our a value is positive. So our range will be negative 19, comma, infinity. This is not a coordinate point. This is an interval notation that says every number from negative 19 to infinity is included in your range. This is not a coordinate point. This is an interval notation. Every number from negative 19 to infinity are included in your range. I use a squared off bracket for this negative 19, but a parenthesis for infinity. The squared off bracket says negative 19 is in fact included, but a parenthesis for your infinity because you can't actually equal infinity, right? We can never reach infinity, so that's why it's a parenthesis. If your graph opened down, it's still the y value of your vertex, but you're going in a downward direction. So your interval notation would look something more like parenthesis negative infinity until some value with a bracket. And that number is still the y value of your vertex. But our answer to our function is that interval notation. Okay, calculating f of x, we have done this before. To find f of negative 2, plug in your number into your function. And then once again, I just need you to type it in your calculator. Which this one happened to also be our vertex. We've already calculated this, but that's how I could ask you to find that for anything. And I can check that on my calculator. Second trace value. What is my x value? Negative 2. Enter. My answer, negative 19. So if I ask you to find f of 7, f of 9, f of whatever, second trace, value, whatever x value. F of 3 is 56. But I need the work in this lesson. Calculators just to check it. And then the last part, if instead of asking you to find f of something, I want you to find the value of x when f of x equals 8. So this time you need to plug that number in for f of x. And then solve. Which you have done by factoring, completing the square or quadratic formula. And when you're done, this one is not, you're solving for x, it's not a coordinate point. Technically it is, because like this is your y value and your answer is going to be an x value, but your answer doesn't need to be in a coordinate point notation. It could be in your set notation. I would accept either way of writing your answer. When you finish this one, then you can get it checked by me, but I'm going to show you how to check your answer. You're going to get an x value. Your answer, once you know it, you're going to go second trace. Value. You're going to get an x answer as your answer. It's -5. And I got my y value to be 8. So yes, -5 is one of the answers. You should check the other one too, though. Second trace, value. My other answer is 1. Yes, it is, because I get 8. So if you type your value in, if you got something that's not -5 and 1, maybe you got -1. When I type in -1, I don't get 8. So I know that this is not the right answer. That you can then go back and figure out where you went wrong. What did you do? That's how you can check your answers. But you have to show your work in this lesson.